Okay, Wildcats. Today we're looking at journal page 46, square root inverses. 4 ways to find the inverse f inverse of x. 1. Graph, reflect over the y equals x line. 2. Table, switch x and y. 3. Algebraic, switch x and y, and resolve for y. 4. Composition of functions. When f of g equals f g of x equals x and g of f equals g f of x equals x, when the result of f of g and g of f is x, and f of x and g of x are inverses. Now, a special note about inverses, the domain and range will switch. Okay, so if you would, update your notes. Now your notes are updated. Let's take a look at our examples. Okay. All right, example number 1. Graph the inverse of f of x. State the domain and range for the function and its inverse. Notice that it says function and inverse. Okay. Now, the first thing we're going to do is I'm going to color code the inverses and the functions. I'm going to do the function in blue, the inverse in orange. Okay. Now, first thing we're going to do is substitute values in for x to find f of x. Okay. Now, we're going to start with 0 and not a negative number because we know the square root of a negative number is an imaginary number. We don't want to do that. So we're going to start with 0. Don't forget the square root is plus or minus. Okay. So that's plus or minus the square root of 0, which equals plus or minus 0, which is just 0. Okay. Now, we're going to do plus square roots of 1, which is a positive 1, but we're also going to do negative square roots of 1, which equals negative 1. Okay. Then we're going to do plus square roots of 4, which is 2, and negative square roots of 4, which is negative 2. Okay. And then we're going to do plus square roots of 9, which equals a positive 3. And we're going to do negative square roots of 9, which is negative 3. Now, the 0 is repetitive because we know plus 0 is 0 and negative 0 is 0, so we don't need to repeat 0. Okay? All right, so now let's graph the positive values first. So 0, 0, 1, 1, 4, 2, and 9, 3. Okay? Now, notice this function. So if we draw a vertical line through this, we call it the vertical line test, VLT. Okay? It only crosses once, means it's a function. And you only find the inverses of functions, okay? The reason I bring that up is because technically square root's plus or minus, so we have points 1, negative 1, 4, negative 2, and 9, negative 3. But we're going to put that in dashed lines because we're not going to consider those right now, because if we include those, this would not be a function, and we're not going to take an inverse of something that's not an inverse. Or I'm sorry, we're not going to find the inverse of something that's not a function, okay? So that's there, but we're going to put it as dash and not include it, okay? All right, now inverse is easy. We just switch the x and y values. We're not going to ignore it. Well, actually, we'll just put them all in. So then that's 0, 0. We're switching. So that's actually 0, 1, 2, 3, negative 1, negative 2, negative 3. And the x values are now the f of x values. So 0, 1, 4, 9, 1, 4, 9. Okay. So we have 0, 0, 1, 1, 2, 1, 1, 2, 3, 4, and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. But let's also include the portion that corresponds to the dash line. So negative 1, 1, negative 2, 4, and negative 3, 9. But again, that's dashed because that dash corresponds to that dash, okay? Now, if they're inverses, they're going to reflect over the f of x equals x line. So f of x equals x line, which is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, -1, -1, -2, -2, -3, -3, and so on. Okay, so if these are inverses, they're going to reflect over the f of x equals x line. Okay, which you can see that they do. Okay, now domain of f of x okay, well, that's brackets 0 to infinity, and range would be bracket 0 to infinity. Okay, and then the domain range of the inverse, it's easy. The range becomes a domain, so bracket 0 to infinity, and the domain becomes a range, so 0 to infinity. Okay? All right, so go ahead and finish up example 1. And brighten this up a little bit and focus. All right, now let's take a look at example 2. Okay, again, I'm going to do f of x in blue and the inverse in orange. Okay? And before I forget, let's go ahead and set the domain blue, domain range of the inverse in blue, and the range in orange. We'll keep things color coordinated. Okay? And let's blur that one more time. All right. Now, you want to be smart with the values you pick. I'm going to pick x as -3 because negative the square root of -3 plus 3 minus 2. Well, the reason I pick -3 is because that's 0. -0 minus 2 is -2, or -2. Now, I'm going to pick -2 as my next value because that becomes 1. So -1 minus 2 is -3. And then my next value, I'm going to choose -1 because, wait, hold on. Make sure -1 is the right value to choose. No, -1 would be bad because -1 plus 3 is 2. Okay, so I'm kind of glad I showed you -1 because that doesn't work very well. -1 plus 3 is 2. That doesn't work. But I almost lost my pencil. Okay, if I change it to 1, 1 plus 3 is 4. This, a positive one, works much better because 1 plus 3 is 4. Square root of 4 is 2. So -2 minus 2 is -4. And then 6. So negative square root of, and 6 works because 6 plus 3 is 9. Square root of 9 is 3. -3 minus 2 is -5. So you want to be specific with the values you pick because it'll help graphing, okay? So graphing is -3, -2, -2, -3, 1, -4, and 6, -5. Now, square roots plus or minus, but we're not going to focus on the dashed lines like we did before because we only need this portion, okay? Now, the inverse is easy. We switch the f of x and x, so -2, -3, -4, -5. Okay, and then -3, -2, 1, and 6. So, actually, let me take a step. Before we graph this, let's do the domain and range. So domain would be bracket -1, -2, -3. So bracket -3 to infinity. And range would be from -infinity to -2. And you want to do this first before you have another graph and it gets confusing. Kind of like what we did before. It's kind of hard to see the domain when you had all the other graph parts. But here, when you have this, it's easier to see the domain and range, okay? Now we can graph the inverse. So -2, -3, -3, -2, -4, 1, and then -5, 1, 2, 3, 4, 5, 6. Okay. Now, the domain and range of this is easy. This becomes a domain, so -infinity to -2, and this becomes a range, so -3 to infinity. Okay. All right, now we want to graph the f of x equals x line. So that's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, so on, and so on this way. Okay, and if they're inverses of each other, they'll reflect over this line. You see they do, so they're inverses. Okay, so if you would, go ahead and finish up example 2. All right, now let's take a look at example 3. Okay, and I don't know why I got blurry and I knocked the camera, but there we go. All right, now example 3, let's color code f of x and g of x. So I'm going to do f of x in purple. And g of x in red. Okay. So we're going to do f of g. So f of g so we're going to substitute g of x into x. So that's the square root of x minus 1 squared plus 1. Okay. The square root unsquares the squared, so you're left with x minus 1 plus 1. Negative 1 plus 1 is 0, so you're left with f equals x. So far these could be inverses. Okay. So now let's do g of f. So now we're going to substitute f into x. So that's parentheses, the square root of x plus 1 minus 1 squared. Okay. Well, 1 minus 1 is 0. So then you're left with the square root of x squared, which the square unsquares the square roots. So then you're left with x. Since f of g equals x and g of x equals x, we can say that f of x and g of x are inverses. Okay, so go ahead and finish up example 3. All right, now let's take a look at example 4. So we need to do f of g. So this is where we're going to substitute g in for x. So that's 3 square root of 1 divided by 3 x squared. So then we'll simplify. So that's 3 times the square root of 1 divided by 3 times the square root of x squared. So we're left with 3. There's nothing you can do with square root of 1/3, so we just leave it as square root of 1/3 times the square root of x squared is x. This doesn't simplify to be x, so we stop because once one of these is not equal to x, then it doesn't matter. They both have to be. So we can say that f of x and g of x are not inverses. Okay, so we'll go ahead and finish up example 4. Okay, now let's turn the page and take a look at the next examples. All right, find the inverse of each function and state the domain or range of each. Now, when solving for the inverse, algebraically, the first step is you switch x and y. So x equals 3 times the square root of y minus 2. Okay. Our first step is we're going to divide both sides by 3. So x divided by 3 equals the square root of y minus 2. We're going to square both sides. So then you have x squared divided by 9 equals y minus 2. Last step, add 2 to both sides. And I think we need to add just one more line to our work. So y equals x squared divided by 9 plus 2. Okay. Now domain and range, we go back to, let me unbrighten the screen a little bit. Original function, that minus 2 moves the graph to the right 2 units, so our domain is bracket 2 to infinity. And the range, it didn't go up or down, so range is bracket 0 to infinity. Now, for the inverse, it's easy. The range becomes a domain, so bracket 0 to infinity, and the domain becomes a range, so 2 to infinity. Okay, go ahead and finish up example 5. All right, example 6. Switch x and y, so x equals 1 divided by 2, square root of y minus 4. Okay. Now, next step is we're going to add 4 to both sides, so that's x plus 4 equals 1/2 times the square root of y. Now we need to multiply everything by 2, so then you're left with 2x plus 8 equals the square root of y. Last step, square both sides. So then you're left with y equals 2x plus 8 squared. Okay. Now for domain and range, let's go back to the original function. This means it didn't go left or right, so the domain is bracket 0 infinity. And then the range, it went down to -4, so range is -4 to infinity. Okay. Inverse easy, range becomes domain, so bracket -4 to infinity. And domain becomes range, so bracket 0 to infinity. Okay, go ahead and finish up example 6. All right. Example 7. Okay, let's change f of x to y, and then switch x and y. So x equals 4 plus the square root of 2y minus 1. Okay, first step, we're going to subtract 4 from both sides, so x minus 4 equals the square root of 2y minus 1. We're going to square both sides. So then you're left with x minus 4 squared equals 2y minus 1. Let's add 1 to both sides, so that's x minus 4 squared plus 1 equals 2y. Last step, let's divide everything by 2, so y equals x minus 4 squared plus 1 divided by 2. Okay? Now, domain at range, let's go back to the original function. That minus 1 moves the domain to the right 1, so it's bracket 1 to infinity. And then range, it went up 4, so it's 4 to infinity. And real simple, range becomes domain, so bracket 4 to infinity. And range is, our domain becomes range, so brackets 1 to infinity. Okay, let's go and finish up example 7. Let's take a look at example 8. All right, first things first, we're going to change f of x to y. And we're going to switch x and y. So x equals the square root of negative x divided by 3 plus 6. Okay, we're going to subtract 6 from both sides. So x minus 6 equals the square root of negative x divided by 3. We're going to square both sides. So you're left with x minus 6 squared equals negative x divided by 3. Oh, now this happens sometimes. I forget to change the x to y, but if it happens, you don't have to erase all your work. You just go back and change each of these x's to y's. Okay, sometimes when you make a mistake, you don't have to erase the whole problem. You just fix a mistake and correct it along the problems, okay? Now, let's multiply everything by negative 3. So we have y equals negative 3 times x minus 6 squared. Okay? Now domain, let's go back to the original function. Now this gets complicated. The negative x means it reflects over the y equals x axis. So it was here. Now it's going to go like this. Okay? So now the domain is from negative infinity to 0 bracket. And the range went up 6, so it's bracket 6 to infinity. And then the range becomes domain, bracket 6 to infinity, and domain becomes range, negative infinity to 0 bracket. Okay, so go ahead and finish up your examples and start working on your assignment, and have a wonderful Wildcat day.